If I'm audible to everybody, just a quick confirmation on the chat window. Thank you, Ankit. And what about others? All of you can hear me loud and clear? Thank you, John. And, okay, so in today's session, we'll be learning about big data, the technology and the framework, how do we handle big data, and what is required to handle this technology. So before we begin, let me introduce myself. My name is Sandeep Agarwal. I will be your guide for next 1 hour on the technology of big data Hadoop. And my total experience in IT industry is more than 18 years plus, and Hadoop experience training plus having some projects done in Hadoop is 2+ years. And I have been associated with Kratoes for the last, you can say, 6 to 8 months, and taking a lot of patches for them. Thank you, Bhargav. So let us kickstart our journey today about big data Hadoop. So in today's, by the end of the session, you'll be able to understand what is big data, what are the key challenges for big data. We'll be introducing to Hadoop and its main characteristics, and the importance of Hadoop and its components in understanding big data technology and running a small, simple MapReduce program or the processing program on HDFS. So we'll be learning all the terminologies, what is HDFS, what is MapReduce, what is Hadoop. And before that, we need to understand what is big data. So when we talk about big data, just a moment, Vishal. Is my voice cracking to everybody? Am I audible? Am I clearly audible, or there's some crack? Voice is breaking. Hello. Background noise is okay, but what about the sound is clear? Okay, thank you, everyone. Vishal, I feel you need to log in again. There must be some issue with your logins. So we were discussing what big data, what is exactly big data is all about. Any data which runs into huge terabytes and petabytes can be considered as big data. And it's a term for collection of data sets so large and complex. So when I say complex, it means that the data can be pulled from various sources. It could be in the form of structured, unstructured, semi-structured. The structured terms means the data coming from your schema-based or RDBMS data sets, and your different data sets coming from social media, your unstructured or semi-structured like XML files or JSON files. So normally when we compile this data in a normal traditional data set, we need to have an ETL tool which will convert unstructured or semi-structured into a structured data sets whenever we use traditional data sets or traditional mechanism to process this data. Now understand that whenever we have this data coming from various sources in huge quantity and at a very high speed, this terminology is called big data. Sometimes people understand, okay, only the quantum of data is called big data. No, it is not that way. Sometimes the quantum may be small, but the sources may be different. Even that data can be considered as big data because that data becomes very complex to be processed in a single framework. So what does big data application allow you to do? They allow you to process any type of data coming from various sources and any amount of data, and that too at any speed the data would be coming into your framework. So big data is basically a term collection of data sets so large and complex. So whenever we are talking about big data, always understand with 3 V's. It could be a higher volume, like a higher size of our data. I could be speaking about higher velocity, like data could be coming at a very high speed. For examples, data coming from your stock markets, your weather stations, your data being generated by sensors, from machines, from different complex algorithms. So whenever you have this type of high velocity data, even that data can be considered as big data, plus data coming from various sources. So always understand that whenever we are collecting data from various sources, we are collecting all the data into one platform, and that platform can be called as Hadoop. So we will be using Hadoop as a basic framework where I would be pulling all data into one framework, able to process them without using any ETL tool, and that too in very quick time. So I repeat again, big data is the term for collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. Now, when you are collecting such a huge data into one framework, and remember data running into petabytes, so I cannot store it on one machine. I need a proper framework. So how would you define that framework? So these are all the challenges which include how do you capture the data, because the first and foremost thing would be for any processing mechanism would be to capture your data into that framework. Once you're able to capture it, then you are able to, then you need to have a capacity to store that much amount of data, because the data would be increasing day by day. Capturing, storage, then run a search analysis or how to share the data across different users, transferring it to from source to framework, framework to back to different sources, how to do analysis on that data, and finally how do you visualize the result coming out of this big data. So these are all different challenges which are incorporated with big data, and that is we're going to study about in big data. How do we handle all these challenges? How do we come across all these challenges? Because mind you, the data is increasing day by day. There is no limit to data. Today we are living in a data-driven world. Everywhere there is around, there is, if you find it's only data, data, data. Everywhere we are basically living in a digital world where everything is communication, everything is happening in through a digital format. Earlier we used to work, we were always having a verbal communication through our normal telephone calls or something like that. But now everything is in the form of digital format. So the amount of data being generated today is very huge. And also remind you that whatever data we are having today, most of the data has been generated in last couple of years only. And the amount of data which is increasing today, it's really, it's humongous, it's very huge. So what will you do with this data? That is the most important thing. You have the data in the domain. There are only two ways: either you use the data or you discard the data. Discarding will not make any benefit. And if you were to use the data, then how would you make benefit out of it? So that is what we are going to discuss about it. How we will use that data. These are different sources from where the data is being generated today. Social media network, mobile devices, ATM, sensor technology networks, and scientific instruments. These are all, and plus we have so many other sources also from the data can be generated and is being generated. For example, if I were to use any structured data sets like Walmart is generating about 2.5 petabytes of data per hour. You have the largest airline, A380, and that produces about, you can say, 4 petabytes of data from one flight from Singapore to London. So every instrument, every action of human being is now being generated data. And how do we capture the data and make best use of it? That is what we call big data technology. This is a small comparison between the structured and unstructured data. As I told you, the structured defines the data like in a schema or a formatted data which has a proper schema attached to it. For example, any data coming from your RDBMS can be defined as structured data. When you compare to unstructured data, the data which is not having a proper schema, for example, your XML, your audio files, video files, text files, email bodies, all your social media data which is generating from Twitter, Facebook, WhatsApp, these all data can be classified into unstructured data. Now one more thing. Now if you see the quantum of unstructured data compared to structured data is very huge. And this is what all the companies are targeting today. Because the life cycle of this unstructured data coming from social media is very short. When I say life cycle of the data means the amount of use you can make of this data is very short, because today what people are thinking, they may not be thinking 2 months down the line. So whatever data is being generated today needs to be captured, it, process it, and get analyzed. Remember, whatever we are having data or whatever likes, dislikes we do on social media, or whatever messages we pass on to our family and to our friends and family members, they are all being processed and analyzed by somebody. After all, we are using a application of some service provider. So the data is processed, stored, and every day the data is processed and then sold as an insight to the beneficiary of the user. It could be a product manufacturer or a service provider. Even today, political parties are getting the feedback or the amount of insight about their own citizens from these social media platforms. And that is why all these companies are thriving today, be it Facebook, WhatsApp, or Twitter, Google. They all are basically able to sell the information to the respective buyers. Okay, sorry. So I was talking about this big data technology. I was talking about the amount of data running into petabytes and terabytes. This is my first page, all of you. I was talking about the capturing, storage, searching, sharing, transferring, analysis, and visualization. Then we discussed about who's generating this big data. There are screens, there are data being generated from different sources, be it ATM, mobile devices, sensor technology networks, scientific instruments, or social media network. And there I was discussing about the growth of unstructured data and structured data. And I was discussing about how this unstructured data is being sold today in the market and people are analyzing it. So the life cycle of some unstructured data is very, very short. So one needs to capture it as early as possible and store it and make the best out of it. Now, what is the technology which is being used today in this for understanding, for processing the data? This technology is called Hadoop. Hadoop is basically a platform, a framework that allows you to store or process large data sets across clusters of commodity computers using simple programming mode. So when I say I need to process or analyze huge amount of data running into petabytes, the very first thing I should understand that how will I able to store that data? Because I should be able to store that data in a very scalable format so that as my data grows, it should not allow me any hindrance or difficulty to add on more data to that framework. So the very first thing which is I need that the framework should be scalable and it should be a low cost framework where I can simply add more machines to my network. So how would I be storing my data? The data would be stored in a clusters of commodity computers. So when I say cluster means a network of machines would be put together. For example, I am having a cluster of 10 machines, or I could say I will be having data servers of quantity 10 machines in my system, and every machine I would be storing some data. For example, if I load a file on my Hadoop systems, whenever I load a file would break down into blocks, and each of these blocks would be stored across each of these machines. There is a fixed size being described to every block, that's upper limit. For example, in 2.x Hadoop, now we are learning about 2.x in the latest versions. It all started with 1.x in 2011, but currently we are, so every each file breaks down into blocks. So that is the way you can only store a file on HDFS or Hadoop systems. Because remember, cluster is basically a network of machines. Now suppose if my file size is 1 GB and I need to upload it on my HDFS or Hadoop systems. Because remember, if I need to process any data, the data has to be first transferred to this framework. So you can say a network of machines. There are various tools available. How do you transfer it? For the my time being, you just understand that you are in a position to transfer this file onto your Hadoop systems. Now, whenever we load this file on my Hadoop system, that file will be broken down into blocks. Now, each block size I've defined in my system as is equal to 120 MB. That is the upper limit. Because we don't define the lower limit, we only define the upper limit. So suppose if I would like to send a file of or load a file of 1 GB on my HDFS, number of blocks created would be 8. It will be down to 8 blocks because every block would be of maximum 120 MB. It cannot have a more than 120 MB because that's the upper limit being set. Now these 8 blocks which you create on your system would be spread across each machine. Suppose my cluster size is 30 machines. That means every machine is having some capacity of storing data and some RAM capacity. For example, I can say every machine has having about, in a cluster, normally you have each machine having 10 to 12 terabytes of data space plus you can say about 16 to 32 GB RAM. This is normally every data node or data server would be configured to. Suppose my cluster size is 30 machines. I'm having a network of 13 machines and this is my Hadoop network. So 8 blocks, every block would be stored on 8 machines. So every single block would be stored. So I'll be consuming 8 machines to store my file. So 8 blocks, one on each machine. So this is what we call distributed storage of data on Hadoop network. So when I'm talking about that allows you to store and process large data set across clusters of commodity companies using simple programming mode. And it's open source data management scale out storage. So every file is broken down to blocks and it is stored across the cluster. This is what we call distributed storage mechanism of Hadoop systems. And how the data is processed, that we look in the second part. This we have already discussed. Hadoop platform is designed to address big data problems due to size of data. So I can store any amount of data in the system because as my data grows, I can simply add more machines. Variety is possible. I can store my unstructured data, structured, semi-structured, any type of data, and the data coming at different speed. Now these are 4 main characteristics of Hadoop. It's reliable. Why it's reliable? So let us understand that first. Why we call the Hadoop systems are reliable? Because the moment we store 8 blocks, that one on each machine. Suppose if this is a network system, if any of the machine has some issues or there are some network issues, remember these machines could be in a single geographical area, it could be in any geographical area. They are not compulsory to be under one premise. We are talking about a network of machines where any machine could be anywhere. And these machines are basically called data nodes. So every data, the machine where data resides are called data nodes. And so here I got 30 data nodes and all these data nodes are controlled by a single master node which is called name node. So we have one name node which would be controlling the entire my cluster of 30 data nodes. Now when I talk about reliability, now remember I have 8 blocks being stored on 8 different machines, 1 block on each machine. Now there are 22 machines which are totally blank as of now, right? Now but out of those 8 machines, if my machine, one of the machines were to be hanged or there was some network issue with the machine, that means I'm not able to process the file. So to overcome that problem, Hadoop allows you to create replicas, and different replicas would be stored across different machines. So by default, the replica factor is 3. And this is configurable. You can modify it, you can change it as per your requirement. So when I say replica factor 3, that means every block will be replicated 2 more times. So you will be having 3 copies in all to be stored across the cluster. So now I'll be having 8 into 3 blocks, that is 24 blocks total being consumed to store this one file. So initially I was storing 8 blocks, but now every block will be replicated 2 more times. So there will be 24 blocks spread across the cluster, and that is how the data is decided on HDFS. So the moment you don't have, you're not able to read the first block, the framework will be able to read the replica block from some other machine. And that is what we call reliability. So Hadoop systems are reliable because it's highly fault tolerant. Though the data is stored across the network of machines, in spite of that, I can still read and process my data. Second is economical. Why Hadoop is economical? Because 2 things. I'm using commodity hardware. The system or the infrastructure which I'm creating is of normal, your not very high-end expensive servers. These are normal machines which we use in day-to-day lives with some amount of hard disk space and a reasonable amount of RAM space. It is not when you compare those compared to the Oracle database servers or very high-end expensive servers. These are not machines which are equivalent to those. So the amount of cost per terabyte of storage data is very less when you compare to different databases. So that hardware is very you don't require the expensive hardware. Plus the license cost is absolutely free. Why? Because we are using open source products from Apache, and these all products are available freely on. You can download them from Apache site. So this is the company which is managing the entire Hadoop framework like Apache Software Foundation. And if you click on download, you can see the galaxy of tools Apache has. You can have Hadoop system, the entire Hadoop ecosystem being downloaded. All the products are available from Apache site. So these are libraries of different. For example, if you want to install Hadoop on your systems, you can just click on Hadoop here and common. And the latest version is 2.7.2. All you have to just download this file, and this is a zip file. And once you download them on your Ubuntu systems, remember you cannot install Hadoop on your Windows. To install Hadoop, you need to have a Linux-based OS. So in case you guys are working on a Windows system, you need to create a VM on top of your Windows. So first, suppose you guys have a Windows machine, then have a VM player first, then create a VM using that. That's a virtual machine, and you can have different one of those, either Ubuntu as your OS, or you can even have CentOS or Red Hat. Then you need to install Java. It's very easy, like in Ubuntu we can just install it by using sudo command, and you can just download from the repositories, and then we need to install Hadoop. After we download that Hadoop zip file from that site to the VM through the VM browser, and then there are certain configurations you need to perform, and then it will be up and running for you. So when you talk about Hadoop, Hadoop is nothing but a framework which will allow you to store your data in a distributed framework. So suppose we are having a cluster of 30 machines, and every machine will be having Hadoop installed, and these all machines will be talking to each other through the master node, which is called name node. So Hadoop follows basically a client server, not a client server, but a master slave architecture. where the data resides on slaves. So master is your name node and your data nodes are slaves. Why it is flexible? Because it allows you to run different programs on the same framework. I can run data sets, I can run process on structured data, unstructured, semi-structured, any type of data. And the last but not the least, scalable. So initially you can start your framework by having 4 machines, 5 machines, and even some people have started this cluster of having 2 machines, 3 machines. So as your data grows, you can increase your machine. So when we talk about cluster size, so what is cluster size? Cluster size is equal to total capacity of all the machines. So a small quick question for everybody. If I'm having 30 machines and 10 terabytes, so what is my cluster size? I have 30 machines of 10 terabytes each. 30 machines into 10 terabytes. That is equal to 300 terabytes of my total cluster size. So that means I can store data up to 300 terabytes on this cluster. And the data would be stored in a divided format. So once I'm loading a file will be broken down to small blocks, and these blocks will be scattered across each of these machines. That is how you store your data on Hadoop systems. But if you're having a replica factor, then you divide by 3. That means you can store only 100 terabytes of data, actual data. If you're having a 3 as a replica factor, because the replica factor is configured by the programmer or the admin. So if you're having 3 as a default replica factor, that means net amount of data which can be stored on your HDFS or Hadoop system is about 100 terabytes. Is that clear to everybody? If I'm having a cluster size of 30 machines or 30 data nodes, every machine is having a capacity of 10 terabytes of storing capacity. My total capacity becomes 300 terabytes. But if I'm having a replica factor 3, that means 100 terabytes of actual data only can be stored. This is the crux of your HDFS or Hadoop system, how you load your data on HDFS. And that is what we call scalable feature. So once you need to add more data to your cluster, all you will do, you'll just simply add more machines to your cluster, which will allow you to store more data on your systems. So these are the 4 important key pillars of Hadoop on which Hadoop runs. Now this is the entire Hadoop ecosystem. If you can see the bottom layer, which is called HDFS, that is where your data resides. And the full form of the HDFS is called Hadoop Distributed File System. It manages your namespace in HDFS as a virtual file system. So whenever we are uploading a file on HDFS, file would be in the form of block, but you can access that file through a namespace. So it provides a namespace by which you can, it's a virtual file system though, and you can access, you can create folders like how we do it in Linux. Starting point is root as a folder. So root directory, you can create subdirectories and further subdirectories and store some files under subdirectory. Then we have a mechanism called yarn mechanism, which is a processing mechanism. So remember, the 2 key parts of Hadoop system are storage and processing. So whenever you discuss about Hadoop or read about Hadoop, always remember Hadoop has 2 main components. That is the bottom line. First is a storage mechanism. The data would be stored, and the second one is processing. Please understand, Hadoop is not a BI tool, it's not a language, it's just a framework where you will be pulling in a lot of data, you'll be storing a huge amount of data, and you can process any amount of data, and that too in very quick time. You can process petabytes of data in minutes, depending upon if you have a good amount of cluster size. So your storage mechanism is called HDFS, where your data resides, and processing is called yarn, which will process your data which is stored in HDFS. So always understand Hadoop has 2 main components, the storage and the processing. HDFS does the storage part, and the processing is done by yarn. So, and the bottom two layers, if you can see, the Flume and Scoop, these are different data loading tools. Remember, I discussed earlier also that the data would be stored or pulled into HDFS. So there are different tools available. Suppose if you want to bring Oracle data into your HDFS, I got 30 years of data in my data warehouse. You can pull that data in quick shot by using Scoop loading data loading tool. I can pull all streaming data like data coming from Twitter or a stock market into my whatever streaming data which is flowing data into my HDFS. Remember one thing, we need to pull the data into HDFS before we start processing. I cannot keep my data outside and process my data in HDFS. That is not possible. So that's the first thing you need to remember. You need to pull the data into HDFS and then only can process it. And that processing is done by yarn. And what are the tools available? There are different tools available like Hive, Take Latin, MapReduce framework in Java. We have a columnar database in the form of X-Base, which allows you to process data much quicker and faster. And there are other frameworks like Giraffe, MPI, and other tools available like Storm, Spark, Solar. Excuse me. So, plus we also have the workflow tool, which is called Apache Uzi, which will allow you to process your data in a scheduled way. Like if you want to run a program at a particular date and time, that you can set it up in Uzi, and Uzi will call the program appropriately. So the key part to understand here is, as a beginner, that HDFS is for storage and yarn is for processing. These are but the tools available to run your process are different. There could be MapReduce framework written in Java. You have a SQL query you can write. If you're not good in Java, you need not to be worried. You can use SQL statements like select star, and those data will be processed using select statements. Plus, we also have a different language called Pig Latin, which is a very, very easy language to learn. And you can also use that data flow language to process the data in HDFS. So this is a part of Hadoop ecosystem. Hadoop ecosystem is very, very huge in fact. So what does Hadoop does? Now we know that how the data is divided, distributed, and stored across the cluster. So Hadoop provides a distributed file system and framework for processing large data sets. So Hadoop is designed to run large number of machines that does not share any memory or disk. Component divides file into small blocks, so we are dividing the data into blocks. And basically the reliability factor is maintained by creating multiple replicas. And then finally, how do we process the data? Once your blocks are available on different machines, and if you're writing a query or firing a query, for example, if you fire a query with a select statement, and these blocks are located on different machines. So your query would be sent to every machine where your blocks are located. For example, in my last example, if I'm having 8 blocks for 1 GB file, and if I were to write a query on that 1 GB data, my my code, you can say the code for processing data would be sent to every data server or data node where my data resides. So what is happening basically, I'm processing these blocks parallelly, independently and parallelly. It is not that every data block would be processed one after the other, not that way. It is not that first block will be processed, then the code will go to the block number 2 and then 3, and then not that way. All these 8 blocks will begin at the same time and end at the same time, provided they have the same amount of data. So all these 8 blocks will be processed separately and parallelly, and that is the advantage. In a simple analogy, if I would like to put this entire process, if you have a 100 man-day job given to you, and you have a strength of 10 people, you would take 10 days to finish the job. But if I were to increase the number of people and reduce the time to process or to complete the job, certainly if I increase it to 50 people, I can finish the job in 2 days. So that is the way it is worked. The more your cluster is spread across, every machine is able to process single block, then your work is done much faster. That is why we say if you tomorrow if your data increases from 1 petabyte to 2 petabytes, but if you have a good proper cluster, maintained cluster, then certainly the time taken to process will not increase. In the same time limit, I can process any amount of data. So what does MapReduce do? MapReduce is basically a program which will be sent to every data block where your blocks are located. That is how your processing happens. These are important components of HDFS and MapReduce. So as I told you, name node is your master node and data nodes. So you'll be having one name node and multiple data nodes. So in this example, I'm having one master node which is name node, and there are two data nodes here. And every data node is processed by a task tracker. Every data node is processed by an individual task tracker, which is a processing mechanism. And the job tracker is a master node just for yarn. The way we have, so yarn HDFS has name node and data nodes as masters and slaves. Yarn has resource manager, or you can say job tracker and task trackers. So these are, so HDFS, the master is called name node and the data nodes are slaves, and these are multiple machines. And every data node is processed by a task tracker. So every machine would be having a task tracker mechanism which would be processing each block. And job tracker is a master node which would be taking up all the jobs from different clients. Remember, millions of jobs would be running on this cluster. In today's world, we have a cluster size of 40,000 nodes, 50,000 nodes. So the job tracker becomes very, very important. It is processing all the queries being fired from different clients. So the master or the admin node for processing is called job tracker, and for the HDFS, the name node is admin node, and every machine is data node which is controlled by task trackers. This is what the diagram depicts. So HDFS is a storage layer, and the programming concept or the framework is called MapReduce or yarn. MapReduce is an entity which is called version 1. In version 2, we call it yarn. So if I'm saying yarn, so it's MRV2, MapReduce version 2. So don't get confused between yarn and MapReduce. So in actual course of line, we'll be learning about MRV2, that is yarn technology. So like it follows a file system of hierarchy, like file and directory hierarchy, and it has the key components, name node and master node, name node and data nodes. Now what does, we all understand data node contains the actual data. Your data would be residing on data nodes. But what would name node contain? Name node would contain your metadata, that is your information about your blocks. Because all that information what we are sending across or different data nodes, that every block would be carrying some information about themselves, like block ID or block location, on which IP address that blocks are located. So name node will be having that information. So whenever we upload a file, a name node will be having a file name, the user identity, like the permission levels, the block, the replica factor, and the information of these blocks. So in this case, if you are having 8 blocks, the file would be having a file name. A file name could be, you can say, abc.txt plus a replica factor. So we can say rp is equal to 3 plus we can say some user ID, who's the owner, so owner 1, plus all the blocks related information. So like block one will be on data node number 1, block 2. Every block will be having some number, unique number, and data number 3, so on. So all these 8 blocks will be, and plus the replicated blocks data will be also stored on this information. So this information is called metadata. So this data resides on name node. Now what happens if the name node fails down? What happens if the name node fails down? There is no name node activity. Your cluster is down because you cannot access the file. The moment your name node is down, the entire cluster is down. So name node becomes a single point of failure. If your name node is down, your entire cluster is down because you will not be able to understand where your block is located. So name node is very important to get your information, and that is why it is called a master. It is having all the details about your blocks which are stored in your system. So that is why this is called metadata. Data about your data. So name node stores the metadata and block to data node mapping. So whatever blocks we are storing it, they are basically stored on name node. All the information about your files which are broken down to blocks, and that information is stored in name node. This is how your name node architecture looks like, or your entire HDFS storage. In this case, you can see the file name is data, which is under /home/m file folder. Excuse me, I'm having a very bad cold today. The replica factor is 5. That means every block is replicated 5 times. And there are about 5 data nodes here, 3 in rack 1 and 2 in rack 2. So you can see the different clients are, some are writing, some are reading. So when you want to read a file from HDFS, a client would first approach name node, take the locations of that blocks, where the blocks are located, and then client interacts with those nodes directly. The data never flows through name node. Client will talk to the data node directly and start reading block by block. For example, in this case, after I loaded that file, if I would like to read the file, I would be reading the block 1, then block 2, and block 3, and block 4, and so on. But the processing is done parallelly. Reading and writing is done sequentially, but processing is done parallelly. Name node keeps the entire namespace in RAM, and so everything is being maintained in the RAM of your name node to have a faster. Plus, they also maintain 2 files, fsimage and readlog. This we can discuss as we will go through the main course outline, just to make you understand where the data resides. This is what we call metadata, the block locations and block IDs. This is all we call metadata of your information. And we already discussed about the data nodes. So data nodes are replicated and stored across, and data nodes also interact with the name node on periodical basis. So it sends a heartbeat to say that they are alive, and they talk to each other. So practically in terms, if I were to show you the HDFS, it will look like something like this. So this is my virtual machine on top of Windows. I'm logging on to my Ubuntu OS. Takes a little while. So when we installing Hadoop, we'll be having two types of file system. One would be own file system. So after installing and configuring, you need to start Hadoop services. The command will be start all.sh. To start your name node, data node, secondary name node, that is the backup of your name node, because your name node is a single point of failure. So after we'll do one thing, we'll create one file here and upload the file on HDFS. And then we'll run our first MapReduce program on that. Basically, we'll run a word count on that program, on that data set, which will give us the count of each word in the text file. So in 2.x we have the resource manager and node managers instead of job trackers and task trackers. So resource manager is a new name given for job tracker, and node manager is basically the task tracker in 2.x. So check my services. These services are running, and if I were to access my Hadoop on my browser, I can also access it using localhost. It allows me to access my Hadoop on my browser. Remember, this is a VM browser, not my Windows browser. So this is the entire says cluster version. Currently, I'm using 2.6.0. It also has its own block field ID. So has the cluster ID. It gives me details about each my name node status. I can also access the file system by using utility browser file system. So it basically follows the same file system like Linux. So now I'll create one directory first. Let me see, I'll first delete the directory. Here I'm just deleting the Kratoes directory if there are any. Okay. So now I'll be creating one directory on HDFS. The command for that is Hadoop FS -mkdir /Kratoes. It will create a folder on HDFS. So I'm using a namespace to create my folder. If I say Kratoes, I can go to that folder. It's a blank folder, nothing is there. So let us have this file kratoes.php. Here is a small file. We are learning group. Hadoop has two main components, HDFS and MapReduce. HDFS is for storing data, and MapReduce is a processing framework. A small file I'll just create. Now I'll transfer this. Remember, this file is up till now on my local file system. So I have to transfer this file on HDFS. Only then I can process this file. So we'll run a small program on this data set on a file, which will give us the count of each word. So how many times I've used HDFS, how many times I've used MapReduce. So I'll run a small program on this, and that will be my first MapReduce program. If I say Hadoop FS -put Kratoes, the file name .txt, and the location will be /Kratoes. Remember, I can have any name. I'm just giving Kratoes.txt just to identify with it. If I click on go, the file has been uploaded. Now if I click here, this is a block details. A block has been created. But the file, the size of the file was very small, 134 bytes only. That is why I could get only one block. Remember, if the size of the file is less than the block size, the block becomes the same block size. It does not occupy the entire block. So every time in the training I have to explain this, that it is only using the block entire if the size of block is more than the block size. If the size of the file is more than the block size, only then it occupies the entire block. Otherwise, it only uses the file size. Now let us process this data using the program, and I have a program written in my system, which is word count. So normally we use Eclipse to write Java programs. It simply has a two-part, mapper and reducer part. Mapper will do the filtration and reducer will do the aggregation on the data coming out from mapper. So we have this file with us. So let us see. We need to first have a jar file. So I have already created the jar file here by using export command. My jar. Now I'll be running the program here. Hadoop. The command is Hadoop jar name. These are simple syntaxes we will be learning through them, and then we'll be calling the class name. So my class name is my word count, and now the input file. So input file is /Kratoes/Kratoes.txt, and you need to specify the output directory where you will be storing the data. So I'll be storing on the Kratoes folder under output. Remember, the output folder is not there; it will create on its own. So you have to specify a new folder name which is not existing in the framework. So whenever you specify the name, the framework will create that folder first and then store the results under that folder. So it's Hadoop jar mywc.jar. My word count is my class name and my input name and file name and the output name. It runs a series of mappers and reducers and process the data. So while you'll be learning the entire course, you'll be learning about what are mappers, what are reducers, and it will be a lot of counters also. So these counters are important to understand. Different, in this case, we're having 49 counters like file system counters, job counters. This gives you a lot of information about how the process was done and achieved. As you can see the browser here, you'll have one more folder being output being created. And under output you can see the file which is part R510. Under source success is a notation file just signifying that the process has been done successfully. But this is a result file which is called part R510. If I were to read that file, I would say Hadoop access-cat slash Kratoes slash output slash part R510. So you can see the result here. So this is the result. A is being appeared one time, and is one, R is one, components is one, and Hadoop is being used 2 times. So if I go to check the data, I can just use. So here you can see this is the actual data. It's been broken down to a 2-column of data set. So I'm using A1 and ones, R1, components 1, data 1, for 1 framework. Hadoop is being used twice, HDFS is being used twice, is being used twice, MapReduce twice, and that's it. As everything is used once. So this is a simple program where I'm running my word count program, and this is how you process the data. So what does Hadoop do? Finally, all of you understood. You are putting your data in Hadoop systems, and you are able to process the data. So as a client, I was firing a query from my local file system. So I ran a command, I fired a query on HDFS using Hadoop commands, and HDFS was able to process the data using YARN framework. So this is what we do in Hadoop system. We are using different mechanisms, and this is all different how the data is stored, and this is the basically the process here. So you can see this is a simple text file. A text file is broken into different lines, and then every word is I'm using as a key value. So every word is broken down to key comma 1. Because every word is appearing once, and then I'm pulling up all the common words into different baskets. In this example, Python was used 3 times. So I'm making one basket of Python and putting all my data into my systems. And this is called shuffling, and then finally I'll be adding up all the because Naga, this is a single file, takes it's a single node cluster. So it takes a little while. Just a demonstration, not the actual data set. But if you're working in a huge amount network system, then certainly the time taken will be. And one more thing, Hadoop is not advisable for processing small files. The amount of time taken for preparation is very, so that you cannot just ignore it. And once you are log on to the real final system, then you can see the difference. Difference in processing your actual data on your database mechanisms and Hadoop systems. It's much faster. Naga, for that you can just contact the Kratoes support staff. They'll certainly help you out. There are many companies who are processing and who are having Hadoop systems. So guys, this was the entire session about the introducing to your big data platforms and MapReduce programs. Any questions, feel free to ask me. I'm open to all of your questions. Hi, Pankaj, how are you? So we were able to show you how the data was stored. Plus, guys, just feel free to ask me any questions. And if anybody would like to join the entire course curriculum, these are the entire breakup of your entire course curriculum. In the first class, we will talk about introduction to big data Hadoop. Second will be our HDFS architecture. Sybil, the Spark is basically an alternate to MapReduce. So first we need to understand what is MapReduce, then we can jump to Spark. It is a more of faster way of processing when compared to MapReduce. So in the third session we will talk about MapReduce. The fourth will be more advanced version of the MapReduce. The fifth and sixth will be talking about different tools available to process your data using pick and hide, scoop and flume again, and it will be a data loading ingestion tools. HBase is a columnar database, like you can create runtime columns compared to RDBMS databases, which is more advanced. And 9 and 10 will be more about UG and project discussion. And at Kratoes, we provide 100% displacement assistance. And once you join the course, you'll be accessing your LMS on lifetime. And any support will be there by 24/7. Currently, Pankaj, I would concentrate on the big data platform only. For other like IoT, you can just check out with the support staff. So currently, these are our corporate partners who are we dealing with on a day-to-day basis, and we have huge demand for people in big data development domain. Certainly, some of the support staff will certainly come back to you. Okay, thank you. Okay, Pankaj. We'll come back after we can talk about that after presentation. Okay, no issues. Thank you, Sanjeev. Thank you. Hey guys, any more questions? Feel free to ask me. Just a moment, Prashant, I'm just going through your question again. Certainly, if you see anybody who has a good eye for data, who understands data very well, can go for big data analytics. Big data analytics is a very, very wide, open, you can say domain where you have a lot of challenges. As a programmer, your challenge will not be to get the answer, but to run your query in the fastest time. Balakrishna, for that you need to get in touch with the support staff, and this is you can reach us at sales@Kratoes or brajesh@kratos.com. These are the local numbers of India and US. If you're calling from US, you can just dial in a toll-free number 646-362-6476. If you're calling from India, you can just dial at 70-2255-1245. Plus, you can also log on to our kratoes.com website where you have all the links available. And yeah, we are recording the session, so you can get a copy of the recording session also. And Prashant, certainly you can join this course and it will be a very boost to you. Prashant, let me also tell you, today data is considered as a commodity. It's been compared to gold and oil, where just like raw oil and raw gold does not fetch you huge value, same thing happens with data. Once the data is processed, it becomes highly invaluable. So data is very, the processed data is very, very expensive, and it's creating wonders for many people. And that is why people are using this framework or technology by which they can process any amount of data in very good time. And that too, any type of data. That is more important. I don't need to convert the data into some sort of a proper type and then start using it. So it's a very, very important, a very, very good framework which can be make best use of any data. And this is just a beginning. And also remind you, this technology is a game-changing technology, just like what we had object-oriented programming about 20 years before in the form of Java or C++. Same thing is happening with this data in the form of big data framework. Sooner or later, everybody have to learn all these technologies because they will become part and parcel of your life. The amount of data today is growing, it's very, very huge and very, very fast. Everywhere, wherever you just look around, we are living in a data-driven world. Everywhere there's data only. And now with the help of IoT, you can see the data, the generation of data will be much more. So guys, if any more questions, or can we wind up the session? I'll get in touch with you with the support staff. Certainly we'll get in touch with you. Just give me a day time. I first need to cross-check because as a trainer, I'm not supposed to talk to my audience directly. So you need to get first, yeah, you need to get the first get in touch with the support people and they will link it to me. Bhargav, for that you need to first join the course, and I can guarantee you once you finish the course, you will be done with all the course what you're talking about, like Scoop, Fume, or you'll be a fully guided person how to use them. So all you have to just join the course, and then at the end of the course, I can guarantee you will be in a position to use them all on your own. That's a guarantee from our side, because we teach everybody from basics. We don't teach like we don't give you a pre-installed package. Everything will be installed on your machines, and there will be more than 60 to 70% hands-on experience in getting. So it's a very, very elaborate and a very, very comprehensive course. We'll be going through it. And I request all of you, sooner or later, just learn this course. You may require, yeah. We are ending it. And thank you all of you for joining the course today. I appreciate it from everybody who joined the course for this session. Thank you. Bye-bye. Okay.